Okay, so we're having our first video for Chapter 9, and we're going to start with doing a little bit of math review of some topics that we're going to be needing. And let me just kind of explain why we need to talk about sinusoids. So you may recall from Chapter 8, when we were solving the second order circuits, we had differential equations like something like v double prime plus 1 over RC v prime plus 1 over LC equal to 0. And that wasn't so bad to solve the homogeneous differential equation. We got our answers and everything was great. The problem is that we are no longer going to have 0 on the right hand side. And the reason why is originally, if you looked at the differential equation we derived, it wasn't 0. It was something like 1 over C di dt, where I was the current source in the circuit. And it was just that every time we did a circuit before, we were dealing with DC sources or constant sources. And if that's the case, the derivative is going to give you 0. So that went away. But now, from here on out, we're only going to be dealing with AC sources. And that means that derivative is not 0, which makes it a much harder problem. Now, it is entirely possible to solve this differential equation with other weird things on the right-hand side that are not 0. You may recall, if you took Math 252, something called method of undetermined coefficients. However, it turns out there's a much more efficient way than even trying to solve the differential equation, and that's going to be called phasors. And phasors are going to be based off of sines and cosines for trigonometry. And it's going to turn out that as long as we can deal with sines and cosines, we can actually solve circuits for whatever you actually have. But we're just going to focus only on sines and cosines here. So in order to do that, we need to talk about that. Now, sines and cosines together, we call them sinusoids. And here is how we're going to draw a formula for a generic sinusoid, generic sine wave. And remember, it doesn't actually matter that we're only writing sine, because a cosine is just a shifted version of sine. So you could just use sine or just use cosine, it doesn't really matter. Now, with that said, we need to know what certain important things are here. For example, this number in front of the sine, which we're calling xm here, that is the amplitude of the sine wave. And if you remember, the amplitude is how high up and how low it gets on your graph. Then the number inside here, the number next to the variable, we're going to use the Greek letter omega for that, and omega is the angular frequency. It's how many radians per second the thing is changing at. On the other hand, we do sometimes care about the regular frequency, and there's a relationship here. Omega is equal to 2 pi f, 2 pi times the regular frequency. Furthermore, we also have this theta thing in here, and that's called the phase angle. That's how much you're kind of shifting left and right on your graph. We'll talk a little bit more about that later. And the last thing on this first slide is the period here, which is the reciprocal of the regular frequency. Notice that it is not the reciprocal of the angular frequency. You can use the angular frequency by doing 2 pi over omega. It's the same thing as 1 over f. And so it's important for us to be able to look at a sine wave and identify these important characteristics, or vice versa, in order to be able to handle problems.